So if you've been asking yourself what is Amazon SQS, how you can use it in your code or in your project, so today we're going to be taking you through what Amazon SQS is, how you can use it in your Spring Boot project or in Java, and how you can produce messages to your queue, read messages or consume messages from the queue, and also dequeue messages that have already been pushed into your queue. So welcome to another cup of code. Let's see what we have today. So first things first, we're gonna start by checking what Amazon SQS is. So Amazon offers a message queuing service. So SQS stands for simple queuing service. So that's what SQS is. So it's a standard queuing service basically, which is the simplest form of a queue. And you also have a FIFA queue that is being offered by Amazon. So when you get to your AWS console, you can just search for SQS right at the top here. So you'll see that Amazon has simple queue message. So that's what SQS stands for. And with SQS, you have two different queue types. So for us, we do have two queues that have already been created, but if you want to see how you can create one, you can just go back to SQS there, and then you can click on create queue. And create queue has a standard queue, which is like they just give you a small description here that at least once delivery message ordering isn't preserved, so there's no priority of how the messages are ordered. You just push messages there randomly and they can be picked up randomly, and that's essentially what the standard queue is. However, on the contrary, a FIFA queue is a first in first out delivery, so message ordering is preserved, which means there is a priority of which message came in first, and that's going to be prioritize according to that. So you have these two type of queues based on the data or the load that you have and the requirements of that data. You can align it to whichever queue that best suits your use case, and then you can complete some details here to say, maybe let's say test queue, and then you can just proceed down here to populate all these other details as you would need the time and the rest of the stuff. So I'm not going to dwell so much here because it's pretty much straightforward with the queues that we already have. Let me just go to services and let me go to SQS. The ones that we already have, which is zip code users queue, and we also have a zip code users dead letter queue. So basically, if anything fails on this queue, we have a dead letter queue that is already in place for us that we can use. So if we go into zip code users queue, we have basically all of these are like default settings. The only thing that is different is that I did enable the dead letter queue, which we will discuss at length in the next video, because for now I just want to just see the feel of the dashboard on Amazon, how to create a queue, and once the queue is there, you have all these details. You can then essentially be able to plug that in. So without wasting much of your time, let's just jump into the Spring Boot code and see how we can plug in we can plug our Spring Boot application into AWS SQS and start pushing messages there. So just to showcase what we already have here, we have a REST API here, Spring Boot obviously, and we say produce, and we then give it our message here. So let's just say test user, and let's run that, and let's see a response there. So this is like the message ID from the queue that I'm getting there. So the message has been pushed to SQS, and that's the message ID. So if I come to my consume API, and I'll see all the messages that I have already in the queue, and let's just run this, and you will see that message came back there. So the moment that I basically consume the messages, it then dequeues them. So if you look at the body is test user, which is what we passed in here. So let's say I decide that we're gonna have test user 1. Let's send that, and that goes through, and then test user 2 and send, let's see, that went through, and we go to let's see our queue here. Let's say purge, let's see, show and purge is currently, no, cancel, we don't want to purge. Actually, we want let's see, where are those messages? Receive messages, that. Yes, I want to poll messages. Yes, poll messages. Yes. All right, so these are the messages that are in the queue right now. So we can see the messages that we have, 4 messages available. And if we go to our consume this side, and we just send that guy, let's see what we have. This should come back in a few. Uh, 200k, but it didn't give us our messages. Well, that's a problem, right? So let's just check this out in our Spring Boot. So there's nothing that it is complaining about. It is super happy. We have messages in our queue. We know that for a fact. Because that is there. So before we jump into our Spring Boot, so this is the configuration basically that we have. The group is com.zipcode, SQS messaging. It's a demo, and we are on Java 17, and we are running Spring Boot 2.712, and that should be basically. We have Spring Web, Lombok, and Spring 2 Dev just for a speedy development on my side. Essentially just need Spring Web for the REST API stuff, and then the one other dependency that we need for Maven is AWS. So com.amazon AWS, and we are on 1.11.163, and that's the version that we have. So with all of those details, let's begin our stuff. So application properties, we have our AWS keys and stuff, so that I would show you because you're gonna see them in the util here that I use. So I use the annotation at service so that I can be able to access the application properties much more easier for me, and it's much more easier to just explain this video without going into the details of add configuration and all of those nitty-gritties. But that will be in a separate video on how to access those configurations in a custom class that you would want to handle such configuration variables or properties. So so we have the AWS access key, a secret key, and we have the queue, and we have the QARN, we have the QURL, and we also have the dead letter queue details provided here. So but for now we will only be using just the queue and the access keys because we need to access our AWS account and be able to perform all of these functions. So those are the configs that we have, and the first things first is always load your AWS credentials so that you're able to log into your account and be able to perform whatever that you need to perform. It could be S3. You follow the same procedure. You start with the AWS credentials and then going into the client that you need to build. So for now, we are building an SQS client. So we want a SQS builder, and we want to build it with credentials. We're going to pass new static credentials, and we're going to give it the credentials that we have there, and we're going to give it the region that we want to be in. So that's fine. Let me see. I'm actually supposed to be in yeah, South America East one, so that one should be fine like that, and it will build the client for us. So this is an SQS client, and in similar fashion with an S3 or any client that you would need to build, you sort of follow the same standard as defined here or as implemented here on this one. So now we have the client that gives us access to the SQS, let's say console in a way, to be able to start using SQS to do a lot of the stuff. So with the SQS client available, we just retrieve that, and we say if you want to create a queue, so create SQS queue, we give it a queue name, and it will just go and create a queue for us in SQS. And based on the details that you would need, you'll have a create a queue request. You just pass the queue name, and then on the response, so when you say SQS client.create queue, it will go and create the queue for you, and you will just get all the details that you need based on your use case. So here we just get the queue URL, and it's able to give us the queue URL, and you can get a lot of metadata and all the details that you would want to see on that queue. So basically for us, we just want the queue URL, and that's it. That's what interests us. So we have the queue created there, and now we want to produce a message or push a message into our queue. The best way is to produce message to SQS, and we just give it a string of message. Obviously, as usual, we get an SQS client builder, which we did at the top. So we get the client, and we say we want a message request, and with the URL, with the queue URL, now we have the URL available, and with the body, we give it that body, and we give it that sort of a delay. And then once we have the request, we then say client.send message, send that request, and we say get the message ID. So if it's a success, we just want to get the message ID. You don't really need to do this, because if there's a failure here, you will get like a failure on the AWS dependency that is there. So it will throw any exception that is there. And let's just go in there so that we can see that interface. So that interface already has the send message result here, which will basically be carrying the message ID and the like. So the error codes, as you can see here, it will throw an unsupported operation exception. So that is what you can expect from that. So it already caters for an error that will be an unsupported exception that will be thrown within this function here. So we don't really need to wait for a get message. If you don't want it, you just leave it at that. But if you want the message ID for reference of what was sent to the queue, you can also get that back, and you can persist it to database, maybe do some operation with it, or push it to another API that will, or the consumer API that will then need to consume that message on the other side. So that's still fine. You can just use the message ID to reference your message that was pushed there. So the next thing then, after you produce or persist a message into the queue, is to consume the messages from the queue from SQS. Like we see now, we have our client as usual, and here I'm just returning a list of the messages, as you can see here. So I do a receive message request. So at the top is send message request, and then on consume is a receive message request, and we give it the queue URL with time seconds, which is 10 seconds, with the number of messages. We just we makes it a 10 because we just want a list of 10 messages that we want to see. and we say the list of messages, SQS messages here. We just say SQS client receive message, and then we give it the request, then get messages, which will give us all the messages that we have an interest in. And then once we get that, we sort of want to do a loop here to just do a printout of all of these messages. And this is a great example. I added this loop so that you're able to see that for each message that you receive back from your queue, you can then run a process for the message based on the object that you have. Could be that on your messages you have a JSON object that is pushed there, then you're able to read that and then or do an object mapper of the message that you receive, and then process that data, persist to the database, or push it to another REST API, something like that. Whatever that you need to do, run some calculations and persist to the database. All of that you can do here as you receive all of your messages from the queue. And then after that, so if you see my comment here, it says DQ message after using it. So also perform steps so to check if the message was successfully processed and stuff. So here you just need to make sure that whatever operation that you will run before that ran through successfully or not, and then you can actually DQ the message if that went well. But if it failed, obviously you don't want to DQ that message. So it's a good place for you to check an if to DQ or not, and if you want to DQ, then you proceed with that one. And after all of this operation, we just return all the messages, because for now we just want to see what we have in our queue, and that's it. So for consume, it's that one. And then DQ finally, which we just having a chat about now, DQ message from SQS queue. We just pass in the message because we do have the message object that we want to DQ at this line here, line 83. So we just say our client and SQS client delete message. Then we have a delete message request similar to the other request, but here we're just passing it as that instance, and then we give the URL, and with the receipt handle, then we say message dot receipt handle, and then it will obviously DQ the message from the queue. So if you want to test this, I'll just uncomment this line here, so to DQ message from the queue. And as you can see here, we do a printout of the messages, so we'll see them in the console, and then they will be DQ'd after they are printed out on the console. So now let's go back to our let's see here, let's go back to AWS. So all of these messages should be cleared after we run the consume API. So we'll see that in a few. Now I've explained the service that we have for our AWS SQS util. Let's see what we have on the controller side of things, which is where the REST API sits. So we have a REST controller and we have an SQS mapping here as usual. And then we do an auto wire of our SQS util. So we just call that SQS config, like you can see here. Then we have a post, which is produce message, and we give it the message part variable, which is the string message here. And then we say the message ID AWS message.produce message to SQS. Then we give it the message that we get from the REST API. So it's going to come to produce message here, and then do a send message request, and then push that to AWS, and we get back the message ID. So then that message ID will come to be here, and then we return that to the user. Message push to SQS, then that's the message ID. So essentially this is what we see on our Postman when we produce. That's the message right there, which is a success. So everything ran through fine there. And then we come back to our consume. So our consume is nothing but a get. And so when we get, we just do consume, and we just retrieve message from SQS. Then we do a SQS consume message from SQS, and which will do a receive message request here, and then give us a full list of the messages, obviously a max of 10, and then we iterate all of them, and then we just get the message body of what we actually push to the queue, and then we do DQ them at this point here, which will delete the messages from our queue, and we will see that in action just now. And then we'll return the list of each the list by this time will have the messages, but after DQ, the queue will be empty, and then we'll see what we have after this particular process here. And think this is the final one, and now we can see the code in action. So let's just go back on the last time so that we see what we have on the queue. Let's just send this. Let's see if this does come back with what we have. All right, so basically this is test user 1, and it's supposed to actually give us a list of up to 10, and it's only giving us 1. I think AWS might just tell us why is it giving me 1, but essentially you get the idea. That's the message that we sent. I think it's the second from last. So let's just do consume again. Let's see that, and now it should be empty because we did a DQ on the consume. Oh, now it came back with the 2 messages that we sent there. So let's see this. Let's go back to our queue and poll for messages. Let's see this. All right, so now we only have 1 message, which means as it consumes, it actually DQs the messages. And let's just click on this one, and the body is test user, and that's the only one that is left in the queue. Let's just wait for it to finish here. 1 received per second, so that's fine. So I think I'm actually quick when I'm actually pushing and pulling, because I do have a time delay on my producer. Let me just check my producer. My producer and my I have a 10 seconds delay here. Yeah, with delay, which is 10 seconds. So I have a 10 seconds delay, which I can actually just fix. Let me just say 1. Let me just say 1. Yeah, that's fine. That's fine. That's fine. That's fine. The delay is there just to like handle the upload and the download from the queue, but essentially you don't really need it. You can just take it out if you don't need that. So if I come back here and I say let's say U1, enter, let's see that U1, then U2, and let's do U3, and U4. All right, then let's check SQS. One message, poll for messages. Let's just say this. Boom. So we do have 1, 2, 3, 4 messages, right? So we have all of those, and obviously there's no priority in this queue. So let's just wait for it to finish. Just wait for it to finish there, and we're just also giving it some nice waiting period there. So messages available, we have 5 messages, which is cool. Now let's just go and consume. Now we expect to see 5 messages here. So it gave me 1, but it's supposed to give me 5. Test U3, I'm supposed to have 5, and now it's giving me 1 again. All right, so I need to check that. I think it's because of the delay that we have here. But now if I poll for messages, you should only remove 2, and I should only have 3 messages because I only got 2 from my request, and my max is 10. So here my max is 10 with max number of messages, which is 10. So it shouldn't be giving me only 1. I should be getting all 5 messages back. But essentially that's what we have, and that's the idea. So we have TU3, TU1, and obviously those get to be they get to be DQ'd as we've implemented here. So essentially our code works as expected. We just need to get all of the messages back from SQS, of which it's taking the delay. It doesn't do it in one request. It takes its time, and that's not a problem because we can just see that everything works fine, works as expected, and we're happy that we're seeing the messages and all is good. We can essentially now call it a day for today, and we'll see more about queues and more about Spring configurations, how we can actually automate like consuming from the queue without actually having all of the consume functions. But for now, everything's good, everything looks good, and I am happy. Hope to see you on the next one. Please do like and subscribe. Until the next one, cheers.